Okay, now if we were to visualize that one, let's say we have our graph on the x and y axis, but this one is odd, so let me see if I can draw one that's odd. Okay, so that's an odd function. Let's say this is a, and this is negative a. Okay, so if we figured out this area, we can call that our A1. And this area, we'll call that our A2. Now remember, both the areas are really the same. But for our below the x-axis, remember, that's subtracted from what's above the x-axis, the area above the x-axis. So A1 minus area 2 is going to equal 0. All right, any questions on this one?
So what did you say was the logic behind the first one? If the function was even, like how does that relate to each other?
Oh, if it's an even function, then it's kind of a mirror image.
Mm-hmm.
So really what you're doing is you're finding the area of half of it, then you're just multiplying it by 2. So if you find the area just from 0 to a, you found that, and you say, okay, instead of finding it over here 2, just, okay, find this one, multiply by 2, and you have the whole thing.
And then the other one is just they subtract from each other, which will equal 0.
Yeah, they subtract. So they're the same size, but they subtract.
Just by looking at the equation of the graph, knowing whether it's an even or odd function,
Mhm.
is that top where it's f of negative x equals f of x.
Yep, and then we're actually going to do a couple of examples of those.
Okay.
So unless you want to graph everything, then you can just find it that way. Excuse me. All right, so let's do our example. Oh, he wants to write in. Okay. Okay, so let's say, for example, I want to know, can the integral from negative p to p of negative 3x to the 8th power minus x squared plus 5 with respect to x be rewritten as an odd or even integral? Okay. So the first thing you want to do is find out whether or not that's an odd or even function. Find out if the function is odd or even by replacing x with negative x. Okay, so if our f of x is equal to negative 3x to the 8th minus x squared plus 5, then our f of negative x is going to equal negative 3 times negative x to the 8th power minus negative x squared plus 5. Now, whenever you have a negative number raised to an even exponent, it's always going to come out even, because each of the negatives will cancel each other out. That's going to equal negative 3 x to the 8th power minus negative x times negative x is just x squared. So you have minus x squared plus 5 which is just our f of x. Okay, so in this case, f of x is, f of negative x is equal to f of x. So f of negative x is equal to f of x. So the function is even. Okay, so since it's even, that means that the integral from negative p to p of 3x to the 8th minus x squared plus 5 is going to equal 2 from 0 to p of 3x to the 8th minus x squared plus 5. Okay, so if it's even, we take it from 0 to whatever p or a or k or m or whatever they're going to use, and just multiply it by 2. Okay, but it all revolves on whether or not that function is odd or even. All right. So any questions on that one?
Is it supposed to be a negative 3 then?
Yep. Because remember that negative 3 was already there.
I know, on the very bottom, where you want to reload it.
Oh, okay, I missed one. Thank you.
On the other side, too.
Yep. Completely missed that one. Let me kind of give it a little more room there.
Is that, the second half is from 0 to p?
Yep, from 0 to p. Because whenever it's even, you really just kind of cut it in half. So instead of from negative p to p, it goes from 0 to p, and you just multiply it by 2. That's only if it's even. All right.
And then would you derive it from there, or would that just be the complete answer that they're looking for?
Oh yeah, that's just the one they're looking for. They just want to know whether it's odd or even and how you would rewrite it. So they gave you like 5 different options. All right. Okay, no one's still writing. All right, looks like everyone got that one. Okay, so let's say, for example, can the integral from negative k to k of negative 5x to the 9th minus 2x to the 3rd be rewritten as an odd or even integer? I mean, not integer, integral. And really, if you look at your exponents, that'll be kind of the giveaway. Because you notice here,
Evens.
all even exponents. So the negatives kind of cancel out and they all come out the same. Here, if you had odd exponents, if you have negative 1 to the 9th power, it's going to give you negative 1. If you have negative 1 to the 8th power, it's going to give you positive 1. So those kind of give it away. Okay, so first, we want to find out if it's odd or even, which you already know it's probably going to be odd based on the exponents, but we'll do it anyway. So f of x equals negative 5x to the 9th minus 2x to the 3rd. So f of negative x is going to equal negative 5 times negative x to the 9th power minus 2 times negative x to the 3rd power. Okay, so this is actually going to equal negative 5 times negative, I guess you could say negative x to the 9th minus 2 times negative x times negative x times negative x is negative x. So it's times negative x to the third power. So the parentheses kind of disappear where you're not taking the entire thing to the third power. It's like negative 1 times x. Okay. So if we factored out a negative from both of these, you'll have negative 5 times negative x to the ninth plus 2 times negative x to the third. And those negatives can just come right out to the front because it's just like negative 1 times all of those. So that's negative 5x to the ninth minus 2x to the third. Where this is actually your f of x. So you have the negative of your f of x. Okay, so since our f of negative x equals the negative of f of x, the function is odd. Okay, so that means that the integral from negative k to k, negative 5x to the ninth minus 2x to the third with respect to x is equal to 0. Down a little bit.
So this only applies though if it's going from like say negative 9 to 9, it won't apply if it's negative 8 to 8.
Oh, it'll apply from as long as it's negative to positive. If it's even, if it's an even function, it'll apply, or if it's an odd, it'll apply. But they have to be going from the positive and negative of the same value. Okay, I'm still writing. All right, looks like everyone's done. Okay, so let's say for our next example, say we wanted to rewrite the integral from negative n to n of negative 4 cosine of x with respect to x as an odd or even integral. I keep saying integer. Okay. So just like before, first thing we want to do is find out whether it's odd or even. Okay. So remember, cosine is actually an even function. But we don't really need that just yet.
It isn't odd or even, not as, right?
Yep, rewrite it as an odd or even function. I mean, even integral.
Oh, rewrite it as a...
Yep. So cosine of x is an even function. Okay, because if you get the graph of it, actually looks like that, and then it goes in the exact same way, so it's a mirror image across the y-axis. Okay. So if we have f of x equals negative 4 cosine of x, then our f of negative x is going to equal negative 4. Don't really need that there. Times cosine of negative x. Now, since it's even, cosine of negative x is equal to cosine of x. So that means this just becomes negative 4 times cosine of x, which is our f of x. Okay, so our f of negative x is equal to f of x. Okay, so we know it's even. So that means that the integral from negative n to n of negative 4 cosine of x equals the integral from 0 to n of -4 cosine of x respect to x times 2. All right, so any questions on this one?
So is sine an odd thing?
Yep, sine is odd. I'm actually going to do one for sine coming up.
Oh, because let's say if it was just sine, then you would just have the equation equal to 0 pretty much.
Yeah. As long as it's going from negative one number to the same positive number. Now, if it was going from like 0 to 5, then it wouldn't do like that. But if it was going from -5 to 5, then it would work. All right, we're still writing. Okay, so if we do one for sine, say we wanted to rewrite the integral from -n to n of -5 sine of x as an odd or even integral. Uh-oh, move that up a little bit. Bless you. Okay. Now with sine, that's an odd function. Okay. So if you have your graph of sine, if you kind of flipped it over the y-axis, then again over the x-axis, that's how you know it's symmetric across the origin. Okay, so since it's odd, sine of -x, I guess you should have moved that over so I'm not scrunching it in the corner. So sine of -x is actually equal to negative sine of x. Actually, cosine and secant are the only two even functions. All the other four are all odd. So that should help. All right, so of course, first thing you do, find out if it's odd or even, which we already know. But we'll go through the steps anyway. Let's say f of x equals -5 sine of x. Okay, so f of -x is going to equal -5 times sine of -x. Since it's odd, that negative is going to go out to the front. So f of -x equals -5 times negative sine of x. And we can actually bring that negative out, or that one, either one, we can bring it out. That's going to equal negative of -5 sine of x. Or our sine of -5 sine of x is just our f of x. So it's equal to negative f of x. Okay, so when your f of -x equals negative f of x, it's odd, so that means, move this up a little bit, that the integral from -n to n of -5 sine of x is equal to 0. right. Any questions on that one? All right. Leave that up for a few more seconds. Horrible time for the furnace to go out. All right, so now we're going to go with use substitution. Okay, so let's say if we let f of x be continuous over the range of g of x, where we have an f of g of x. Okay, so you really just have a function within a function. Okay, so let's say if we let u equal g of x, then that means the derivative of u, straighten that g up a little bit, equals g prime of x with respect to x. We're solving using the differentials. And our g prime of x is continuous over the entire interval. Then if we have an antiderivative, we'll call capital F of x. And the integral of f prime of g of x times g prime of x with respect to x is equal to the integral of f of g of x plus c. Now, since g of x is equal to u, we can just make that the integral of f prime of u, and our g prime of x dx, remember that's our du, equals the integral of u plus c. Okay. And actually this just goes back to, and actually we can kind of separate that. So if you remember, that the derivative of f of g of x is just f prime of g of x times the derivative of what's inside, which is g prime of x. All we did was integrate both sides, where the derivative and integral cancel each other out. So f of g of x equals the integral of f prime of g of x times g prime of x with respect to x. Or you can just call it f of u. Equals the integral of f prime of u times du. Let's bring that up a little bit. Alright, so, oh, you want to still write in? Oh, I'll leave it up there for a few more seconds. Alright. Oh, might as well go ahead and restart it since